In today's presentation, I will discuss the few problems on Module 4, where whatever the problems what we looking or gone through under Module 4, I'll just take up some problem and I'll try to discuss over here. So in Module 4, what we discussed is the Fourier transform is a major concept. That is what we saw over there. We discussed about properties of Fourier transform and the problems with respect to the Fourier transform identification and inverse Fourier transform and the problems. The given any x of t like a continuous time signal that it need to be solved in the form of a Fourier transform or in a inverse Fourier transform by applying the properties of a Fourier transform. So these are the few fundamentals which is already we discussed in the regular previous sessions. Also, we discussed about the discrete time Fourier transform, its property and the problems on the discrete time Fourier transform, where in the discrete Fourier transform the many problems are discussed out of some model question paper, also problems also will be solved. But with regard to Fourier transform, some problem model question paper problems which is yet to be solved, and that I'll discuss over here. So coming to the first problem statement here is the find the Fourier transform of a following a signal. The signal is x of t is equal to, we have a section A, so there are two set of problems to find the Fourier transform of a given signal. The first signal x of t is equal to delta t plus 1 minus delta t minus 1, so that is nothing but a delta function at time shifted of t equal to minus 1 and t equal to 1, we have delta t. So what we need to calculate is a Fourier transform of x of t. So we know the equation x of j omega is equal to integration minus infinity to infinity x of t into e to the power minus j omega t dt. So this is what the equation where we need to substitute delta t plus 1 minus delta t minus 1 for x of t. Substitute it, but I'll split this equation integration minus infinity to infinity delta t plus 1 with the e to the power minus j omega t. Okay, t is missing here, you can take it dt here, minus integration minus infinity to infinity e to the power delta t minus 1 into e to the power minus j omega t dt. So applying the shifting properties as per the delta function or impulse function, so t here is the shifted version is t equal to minus 1, so when t equal to minus 1 we have e to the power minus j omega t. So this is from this to this as a shifting property of impulse function. Coming to this, the shifting impulse function is a shifted version for t equal to 1 here. So at t equal to 1 we have e to the power minus j omega t for this set of units as per the impulse function properties, shifting properties. So e to the power minus j omega t when t equal to minus 1, e to the power minus j omega t when t equal to 1. By substituting, what we can get is oh sorry, it's t equal to 1 means we need to have the e to the power j minus j omega. So I forgot to mention about substitution over here. For t equal to 1 it should be 1, not t. So e to the power j omega minus e to the power minus j omega will get t is equal to 1 here. So what is going to happen, divided by 2j into 2j, so we can have sine omega with 2j is going to be remained over here. So 2j into sine omega, not t here, sine omega is the answer, final answer for the Fourier transform of a given x of t function here. The second set is x of t is given is equal to a over the time interval minus t to t. So I have to calculate Fourier transform of this, else it is 0. So x of j omega, we have the equation for Fourier transform x of j omega is equal to integration minus infinity to infinity x of t into e to the power minus j omega t dt. So x of t is equal to a over the time interval minus t to t, substituted, and apply the integration after simplification e to the power minus j omega t by j omega over interval minus t to t. Substituting that, first term is e to the power minus j omega t minus of e to the power minus minus becomes plus j omega t with a by j omega with minus sign, minus taken inside, so e to the power j omega t minus e to the power minus j omega t into a by j omega, so divided by 2 j multiplied by 2j. So say after simplifying, I can get for x of j omega as 2a by omega into sine omega t, that is capital. So this is how we can directly solve the Fourier transform functions. One more problem statement is now a little bit uh, mm, advanced or a little bit changed with respect to the questions. So sketch the signal and then find the Fourier transform. This is quite a little bit changed. So x of t is equal to r of t minus 1 minus u of t minus 1. So it's given. So I have to sketch the graph for this x of t. So let me sketch r of t means it is continuous increasing the value with respect to time from 0. So it is the waveform is like this. For r of t minus 1 is the r of t which is shifted with 1 unit, so waveform will be like this. If you subtract, what is going to be happen, the waveform is till here to here value is there, then each value is difference is 1, but constantly it is subtracting. So the waveform after r of t minus r of t minus 1 I am getting like this. So minus u of t minus 1, that is nothing but t minus 1, u of t minus 1 is like this. So from this graph I subtract this, means I will remain only this portion. So that's how I just taken the graph for x of t is equal to t over the time interval 0 to 1. So that is what the observation or the equation for x of t is equal to t for 0 to 1 for time interval. So for this I have to find the Fourier transform. So Fourier transform, it says x of j omega is equal to integration minus infinity to infinity x of t into e to the power minus j omega t dt. So x of t is equal to t over the time interval 0 to 1. So substituted, then taken integration for t into e to the power minus j omega t. The first term as it is, integration of second term minus differentiation of first term, and the integration of second term, a whole term is integrated again, so I'll get this term. So apply the limits 0 to 1. So after simplification I can get for x of j omega is 1 plus j omega into e to the power minus j omega minus 1 divided by omega square. So here simplification you can try. So directly taking the j omega where j square is taken, so we just taken sign is changed over here, omega taken as a common term of from this line to this line. So this is the simplification term, you can take it, but this is how we can solve it from Fourier transform for the given x of t. Moving on to the next problem is the quite bigger, but this is mentioned in the model question paper. Very interesting and lengthier question it is. You can go and look into this. The given Fourier transform of x of t is x of j omega is given. So Fourier transform of x of t is given, that is x of j omega is equal to j omega divided by minus omega square plus 7 j omega plus 6. So for this, find the Fourier transform of x of t. So Fourier transform of x of t is given. So from that I have to doing inverse I can find x of t, but I am not having x of t again. I have to do x of for t minus 8. So for this I have to find Fourier transform. So the same thing I can apply also for same x of t. I have to integrate it and then apply the Fourier transform of that. So this is a long process where we have x of j omega, we don't have x of t to make this time shifted version or integration of x of t. So I have x of j omega. So from x of j omega I have to go and find x of t. After finding x of t, what I can do, I can do time shift and also integration. Then for that I have to take Fourier transform. This is what the lengthier process over here. So first, the portion of this solution is to find x of t from x of j omega, nothing but I have to do inverse Fourier transform operation. So given is x of j omega is equal to j omega by minus omega square plus 7 j omega plus 6. So I'll write minus omega square like minus 1 into omega square. So minus 1 is nothing but I can also take j square is minus 1, so j square into omega square I can write it as j omega whole square plus 7 into j omega plus 6 divided by, in the numerator we have j omega. So in the denominator I can split into the two term as x of j omega is equal to j omega divided by j omega plus 6 into j omega plus 7. It will yield with this term. So this simplification I can do with the help of inverse Fourier transform, however it is required, but I'll solve this with the help of partial fraction, though this type of problem we solved earlier. So using partial fraction I'll try to simplify this particular x of j omega. So a by j omega plus 6 plus b by j omega plus 1. After simplification I can find the a value and b value. A value I'll get at 6 by 5 by using partial fraction. B value I'll get as a minus 1 by 5. So I got x of j omega. So with the help of the standard formula, it looks like e to the power the 1 by a plus j omega means its inverse Fourier transform is e to the power minus 80 into u of t. So this x of j omega now we have in the standard form 1 divided by a plus j omega, 1 divided by a plus j omega in that particular form with some constants. So by applying this formula or this condition, however we solve this type of problem, so this condition over to this, so we have a is 6 for the first portion and the second portion we have a is equal to 1. So what we can have after taking inverse Fourier transform for this x of j, 6 by 5 is a constant with e to the power minus 6t into u of t. Here is 1, so minus t I'll get in the numerator for exponential. So minus 1 by 5 is a constant as it is e to the power minus t into u of t. So this is what x of t I got, 6 by 5 e to the power minus 6t into u of t minus 1 by 5 e to the power minus t into u of t. So I got x of t from x of j omega. Now for this x of t I have to do these two, then take Fourier transform of that. So I'll keep remember this equation x of t. So I'll move further for the first set. Later I'll check with the second set. The moving to the first set is x of 4t minus 8. So instead of x of t I have to do 4t minus 8. So replacing t by 4t minus 8 is what the second set. I'll just a portion I'll do, replacing for t by 4t minus 8 for x of t. What I can get is 6 by 5 into e to the power minus 6 t replaced by 4t minus 8 with the u of t replaced by 4t minus 8 minus 1 by 5 e to the power minus t replaced by 4t minus 8 into u of t replaced by 4t minus 8. So we had now x of 4t minus 8. For this I have to take Fourier transform. So from Fourier transform we have equation x of j omega integration minus infinity to infinity x of t into e to the power minus j omega t dt. But instead of x of t I have to find the Fourier transform for x of 4t minus 8. So x of t in the place I'll replace x of 4t minus 8. That means this value I'll substitute over here, then I'll simplify. I'll split this equation. Over here you multiplied 6 into 4, 6 into 8, so I'll get this term, and for the second term also 40 minus 8. You can look into this term, e to the power 48 e to the power minus 24 t separated, e to the power minus j omega t taken inside, and e to the power 8 e to the power minus 40 e to the power minus j omega t inside, splitting the integration term to separately into this term. So under first set of integration where I taken the lower value is equal to 2 instead of minus infinity. So why is means we are considering the integration range 2 to infinity because u of t for u of 4t minus 8 is equal to 1 in that duration. So if I say u of t is 0 to infinity, u of t minus 8 means it is 8 to infinity value is equal to 1. But t replaced by 4, that means I just taking the time compression dividing the 8 by 4 means it is reaches to 2. So from 2 to infinity we will have a value for u of 4t minus 8 equal to 1. So 2 to infinity, that's why we taken this integration range. So in that place we have u of 4t minus 8 becomes 1 for both conditions here. So that's why integration range is 2 to 8. Out of this 6 by 5 e to the power 48 is constant taken outside. For the second part is 1 by 5 e to the power 8 is constant taken outside. So only integration remaining for e to the power minus 24t into e to the power minus j omega t. For the second portion, e to the power minus 4t into e to the power minus j omega t, they clubbed together, taken integration, applying the integration limits. So after simplification, I can find the x of j omega for x of 4t minus 8. We have e to the power minus 2j omega into j omega divided by 24 plus j omega into 4 plus j omega. So this is how I can find the Fourier transform for x of 4t minus t. So this is the first portion of the problem, this particular problem, and second portion for the same x of t I have to do integration. Then for that I have to do Fourier, is what they asked. So I'll take that portion again. The Fourier transform for integration minus infinity to t with x of tau d tau for x of t. So we have x of t earlier we calculated. We got x of t is equal to 6 by 5 e to the power minus 16 into u of t minus 1 by 5 e to the power minus t into u of t. So for this I just need to do, this is what x of t, for this I have to do integration minus infinity to t. So taking integration minus infinity to t with the x of tau is wherever t is there, e to the power minus 6 tau u tau with the e to the power minus tau u tau. This is what how we taken with the d tau. So taking integration separately for this term, u of tau becomes 1 for the range of 0 to t. Over here also 0 to t we will have, take integration, simplify it, I can get 1 by 5 of so 1 by 5 of e to the power minus t minus e to the power minus 60. This is what integration for x of t over the interval minus infinity to t. So I taken separately as z of t. So now for this I have to take Fourier transform. So nothing but I am saying for Fourier transform for z of t. So Fourier transform z of t I can mention as z of j omega, which is equal to integration minus infinity to infinity z of t into e to the power minus j omega t dt. So this is as per the formula for Fourier transform. So I just instead of x I just taken z, that's it. So substituting z of t, that is what done here. But z of t, whatever we calculated z of t, the integration limits for u of t, that is defined from 0 to infinity values. So with that remembrance for z of t should also be with the u of t term. So this need to be defined, this z of t term need to be defined with the u of t. So the range should be, now I can minimize 0 to infinity. So 1 by 5 is a constant I taken outside. So integration limit 0 to infinity with e to the power minus t minus e to the power minus 60 into e to the power minus j omega t dt. So separately multiply it, separate it, take integration, then simplify it. What I can find z of j omega for this integration portion for x of t will be 1 by 1 plus j omega into 6 plus j omega. So this is what we can calculate now, the j omega. So the Fourier transform of integration minus infinity to infinity x of tau d tau. So for calculated x of t. So this is what the portion. So till these two sets all together, the three page where I considered three different slides where I changed, out of this entire portion can have asked for 10 marks and more than that. So this is a bit lengthier, the solution is a bit lengthier, but you just need to be focused how it need to be solved and how it need to be identified. So when I taken two sections of tau in terms of calculations and the Fourier transform. So moving on to the next problem, where this is the computing the Fourier transform for the signal x of t is shown in the figure. So we have x of t which is shown in figure. For this I have to find the Fourier transform. So from the figure what we can find, we have amplitude for x of t is equal to 1 for minus 1 to 0, and amplitude is equal to 2 from 0 to 1, amplitude is minus 1 from 1 to 3, else it is 0. So this is what I just taken. So as per the Fourier transform equation, we have x of j omega is equal to integration minus infinity to infinity x of t into e to the power minus j omega t dt. So where I'll just substitute this minus infinity to infinity to range. So minus 1 to 0, we have x of t is equal to 1 into e to the power minus j omega t dt. So next range is 0 to 1 for integration, with the amplitude is 2 for x of t, that is into e to the power minus j omega t dt as it is. Next range is 1 to 3. So for the integration, with x of t is minus 1 e to the power minus j omega t dt, else all is 0. So not need not to be considered that different ranges. Apply the integration, then apply the limits, simplify it. I can find the final answer for now. This for x of t, as in terms of Fourier transform, x of j omega is equal to 1 by j omega of 1 plus e to the power j omega minus 3 into e to the power minus j omega plus e to the power minus 3 j omega. So this is how we can find the Fourier transform of given x of t. So please look into the problems earlier what we discussed under Fourier transform and also discrete Fourier transform. So entire this particular module is talking about the Fourier transform, nothing but this is a Fourier representation of non-periodic signals, which is done under the module 4. So keep looking onto the all the different concept properties of a Fourier transform. Discrete Fourier transform is also very important. You need to give a focus on to that also, along with the problems what we mentioned in the previous sessions and this particular revision sessions or overview sessions. Please look into the different set of problem. Keep on learning. Thank you for listening.